Hello everyone, in this tutorial we will have a look at how to send a raw CCSDS packet in the PUSopen framework. The format of the CCSDS packet was standardized by the CCSDS for the first time in 1984, and since then it was used as a packet format for exchange of the data between the subsystems on board of the satellites and also between the satellites and the ground station. The CCSDS packet has two parts. It has a header, which says whether the packet is telemetry or telecommand, and it states the API ID. And then it has a custom payload, which is usually split between the secondary header and the custom data. In this tutorial, we will create a CCSDS packet in the PUSopen framework, get the byte stream, and then receive that same packet back into the stack and get the notification that we have received the packet. So let's go ahead and do that. Okay, we'll start with including the header files. The only header file that we need to include from the PUSopen is pusopen.h. It internally includes all the other header files. But what is important for this demo is that we will configure the packet services layer. And that's the layer that creates the CCSDS packet, and then on the reception side it will consume the packet and it will tell us what's inside. So for the packet services layer, we need to configure the send buffer size, which should be large enough to accommodate one single packet, or well, the largest packet that your application will create. Then the same for the reception side, and then the type of checksum that will be added at the end of the custom payload in the created CCSDS packet. Then we'll create an instance of the PUSopen configuration. Since there is no malloc call, there is no dynamic allocation inside PUSopen. We need to do that here statically. Then we will create an instance of the fast layer, and that's the lowest layer in the PUSopen stack. It's the layer that actually takes the CCSDS packet and wraps it into a serial frame like HDLC. We'll need a short function to initialize the PUSopen stack, and it's a single API PO init. We will set the API ID of the current application process to 3, and then we will take the created FES instance and tell to the PUSopen, okay, this is our FES instance that you should use. Okay, let's define a few variables. I will explain them later. We will call our initialization routine for PUSopen. We'll clean the request and information structure. So now let's do the sending part. I will put a comment here. So we will start with the sending part. So let's fill the structure for sending the packet, descriptor of the packet that we want to send. And we will say, okay, we want to send telecommand. We want to send it to API ID 3, so application process ID 3. It will have a custom payload, which we have defined above. Here, 4 bytes, 1, 2, 3, 4. So the length is 4, and it doesn't have any secondary header. We only have this custom data 1, 2, 3, 4 that we want to send. Okay. Now this is the important part here. We will call the APIs to first create a packet inside a PUSopen, and that's this call here, PS request, and we will pass packet send structure into it, and then we will call the API PO frame, which actually takes the created CCSDS packet from the PUSopen framework and then wraps it into this HDLC serial frame, so we know on the serial link, or well, any data bus that has a sort of serial way of sending the data, we will know where one packet ends and another begins. And the result, the byte stream, will be stored here in this buffer, and we will get the length of the created serial stream. And then we will do the reception part. I will again put a comment. Okay, so this is the reception part, and in the reception part we will take the created byte stream, which we have in the buff, and we will byte feed it back into the PUSopen stack. Now we will ask PUSopen to look into the received byte stream and see if it recognizes the full HDLC frame, and then inside it the CCSDS packet that we have sent in the code above. So that will be here, and the result will be stored in this structure here, packet receive. So that's the structure that we have defined here on top, packet receive, and that contains the information about whether the packet is telecommand or telemetry, for which APID it is, and so on. So if we have succeeded, if we have received it, then we will print out all of the information about the packet from this packet reception descriptor here, and I will close the main function, and that's the end of the example. So let's go through it once again. So we have included the PUSopen.h file, we have included our configuration file for the PUSopen, then we have created an instance of the PUSopen configuration and the FES layer, so the layer that is encoding the CCSDS packet into a serial frame, HDLC in this case. We have initialized the PUSopen stack and set the APID to 3, so we know when we will receive the CCSDS packet it will not be rejected because we will send it to APID 3. Then here we have the sending part where we have filled the structure pkt send, and we said that it will be telecommand, it will be a destination APID 3, so the same as we have defined in the code above. It will have a custom payload of the length 4, and it doesn't have any secondary header. So now we will call the PS request to create a CCSDS packet, PO frame to get the byte stream out, and then take that byte stream in the reception part and feed it back into the stack byte by byte. And then we will ask PUSopen, hey PUSopen, did you receive any serial frame and in it a CCSDS packet? If yes, then we will print it out. Okay, so now we will build it. Okay, it built well. You can see this is the linking here. So all looks good, and now we will run it. And we can see that we have received the CCSDS packet of a type telecommand to APID 3. There is no secondary header. You can read some more information from this reception descriptor, like a sequence flag and a sequence counter. And the payload was 4 bytes, and those are the 4 bytes that we have defined here at the beginning of the code 1, 2, 3, 4. Okay. This was a short tutorial showing how to send a raw CCSDS packet and receive it back into the PUSopen stack. If you want to try this example, you can download PUSopen evaluation version at our website PUSopen.com. Just fill in the registration form and we will send you your private PUSopen download link, and you will be able to try this example and many others. If you have any questions, contact us at contact@pusopen.com. My name is Slavo Petric and I'm looking forward to talking to you.